shifting the position of equilibrium. So we talked about how an equilibrium will be set up if you have a reversible reaction, and if you wait enough time, you'll have a dynamic equilibrium established. Dynamic because the forward and reverse reactions are happening at the same time, and an equilibrium because at any moment in time the quantities or the concentrations of the reactants and the products are constant. It doesn't mean that they are the same. They can be very different. But if you take a snapshot now and then take a snapshot in 5 minutes, there will not have been a change in the concentrations or the quantities, number of moles of the products and the reactants. So it's constant over time. Now, we can change the position of the equilibrium. We can make more reactants or we can make more products by changing the conditions of the system. Now, what does that mean? It means if we change, for example, the concentration of the reactants or the products, if we change the pressure in gaseous systems or the temperature, we can cause the equilibrium to, and here's the word, shift to the left or to the right to make more reactants or to make more products. To do this, or to describe this, we can use Le Chatelier's principle, which essentially says that if an equilibrium is subjected to a change in conditions, then the system, the equilibrium, shifts in order to counteract the effect of the imposed change. Essentially, in layman's terms, if you do something to the equilibrium, it reacts and it does the opposite. Okay, so let's start with concentration. If we increase the concentration of a reactant, the equilibrium shifts to the right to produce more products. If we increase the concentration of a product, the equilibrium will shift to the left to make more reactants. So let's look at a specific example. So if we mix chlorine with iodine chloride, then they'll start to react to make iodine trichloride, as shown in the equation. Now, if we leave this for long enough, an equilibrium will be set up. So each of the amounts of these three chemicals, the two reactants and the one product, will be constant over time. This is pale green, ICl, iodine chloride, is brown, and iodine trichloride is yellow. So if we do something to this equilibrium, we can see what happens because we can see a change of color. Okay, so here, thinking about Le Chatelier's principle, if I add more chlorine to this equilibrium, what the equilibrium does is it says, hang on a second, you're not going to increase the amount of chlorine in my equilibrium. I'm going to shift to the right to try and reduce that effect. I'm going to make more iodine trichloride. So the effect of adding more chlorine, well, the equilibrium becomes more yellow because more iodine trichloride is made. Okay?